So we've obviously got today's lesson. Next week, I see you on Wednesday, and then I don't see you again until Friday. Now, because you guys are in school one day, either Monday, Tuesday, Wednesday, Thursday, I think we'll leave the Wednesday lesson. Okay, so, and that also just gives you a bit of time to get up to date with the bits and bobs you're doing for me and Mr. Kent. And you never know, it might just free you up a bit of time to get one of the assignments done. That would be great if you could get it done. So basically, 3E is what we were doing yesterday. 3F is going to be what we're looking at today. So really the deadline for both of these exercises, please, is next Friday. So on Friday, we'll carry on and look at recurrence relations. We're not a million miles off the end of the chapter. I think there's another small bit and then some modelling and then the end of the chapter. But I'm not going to put the, I don't want you rushing ahead and doing the this unit test ahead of the game. I'd rather you went back and caught up on some of the ones on your to-do list. Okay, so in summary, we won't have a live lesson again until next Friday. Okay, so sigma notation. Now, some of you may have come across this in your travels, or maybe not. The sigma just simply means the sum of. So if we just take this first one here, what this one here means is that we're just going to, it's the summation of what you get when you substitute all the way in from r equaling 1 all the way up until r equaling 5. So like it says, you substitute in r equals 1, get a number, r equals 2, get a number, r equals 3, get a number, 4 and 5, and so on. Okay, that's what it means. It can give you an arithmetic series, just like that first one does. You can see we're just going up by 2 each time. Or it could indeed give you a geometric series. So don't think of this sigma notation stuff as being unique to either one or the other. It can apply to both. Okay, so really, all you have, the only learning point is absolutely common sense, really, is just set the scene. Just start plugging in from r equals 1 up to r equals 20. Clearly, you don't get that far. You just do a few. Just substitute a few in until you get the pattern. So when you substitute r equals 1 in, 4 1s are 4 plus 1 is 5. When you substitute 2 in, 4 2s are 8 plus 1 is 9. And just do 2 or 3, and it will give you the, and then you can just reflect on those that you've got and then see what's going on. So clearly we can see we're going up by 4. So, and that our first term is 5. We know there are 20 terms from the number at the top of sigma. By the way, I've no idea why we say r equals 1, but we don't say r equals 20. It's just, I mean, that's what it means, but for some reason we just only do the r equals bit at the bottom. So back to this question. So we can clearly see that a is 5. Our common difference is 4. We've got 20 terms. Then you just plug it into the appropriate arithmetic series formula. Okay, and on this one, again, exactly the same strategy. Just like it says over here, substitute k equals 1, k equals 2, and so on to write the first few terms of the series, and then this will just give you the pattern. Okay, so here we just substitute in. You don't overly worry about trying to reflect on what it is at the beginning. Just substitute a few in, then step back and say, okay, what have I got? Well, clearly I'm multiplying by 3 each time here, with my first term being a, and I've got the 12 terms. So I can see that's a geometric series. So I just use the appropriate geometric formula. By the way, you see in the corner that that's how it looks in the formula booklet. Okay, so just to recap, we're given both the versions for summing in an arithmetic series, and we've got the sum for a specific number of terms in geometric, and the sum to infinity when the modulus of r is less than 1. So just remember that's what we're given. Right, the only point I wanted to clarify, and again it's common sense when you think about it, if you get a question like B where it says what's the sum from the 5th term to the 12th term, the way to do this is to start off by working out what the sum is for the first 12 terms. Okay, so ignoring starting from k equals 5, and then take away the bit that you don't want. Now be careful, you substitute in then 4, not 5. Okay, we do want it when the sum is 5, so we don't want it when for terms 1, 2, 3 and 4. So for part B, work out the sum for the first 12 terms, work out the sum for the first 4 terms, not 5, and then subtract one from the other. And I think, folks, that's it. I think from memory, that's yes. Then that just takes us into 3F. So some pretty easy stuff at the beginning. You know, feel free to dot around, and just sort of, you know, just dot around the exercise. I don't think any of it's too particularly challenging. And yes, so really by Friday, I just want you to feel confident with those questions. Oh, what's going on there? Why have I jumped through? Oh no, 7 to 8. That's right. That's all fine. Yep. Yes, and then that's where we'll go for on Friday. So have a good weekend, guys. I don't see the need to keep you any longer. Okay, cheers, guys. Bye.
Thank you.
Cheers, guys.
Thank
Bye.
you. Bye.
Bye. Bye, everyone. Have a good weekend.